Assalamualaikum warahmatullahi wabarakatuh and good day. So this video will discuss two examples. One example for Fourier Sine series and one example for Fourier Cosine series. Okay, look at the example 4.8. Sketch the graph of the following function ft equals to t squared, where t from minus 2 to 2, ft plus 4 equals to ft. Then we know that the L is equals to 2 based on the one complete cycle of the sketch is from minus 2 to 2. With the fundamental period is t equals to 4 over the interval minus 6 to 6. Determine whether the function is odd, even, or neither function. Hence, find the Fourier series of the function. So this is a solution. When we sketch the function from minus 2, okay, from the interval minus 2 to 2, so this function ft equals to t squared. Alright, then as t increases 4 unit to the right, increases 4 unit to the decreases 4 unit to the left, okay, the function will repeat itself. So this is how you sketch the periodic function. Then based on the plot, we can say that the function is an even function since it it's symmetrical about the y-axis. Okay, and f minus t is equals to ft. Okay, then therefore the function is an even function. We're going to use Fourier series. We're going to find the Fourier series using Fourier cosine series. So the formula is ft equals to a naught on 2 plus the summation of n equals to 1 to infinity a n cos n pi t on L. Okay, we know that L equals to 2 based on the function given, t from minus 2 to 2, one complete cycle from minus 2 to 2, therefore L equals to 2, and you have to write down that Pn equals to 0. Alright, so this is one of the properties of a Fourier series, Fourier cosine series, where Bn equals to 0. Okay, then a naught equals to, the formula of a naught is 2 on L, integration of ft with respect to t from 0 to L. Okay, we solve the integration in half cell, okay, instead of full cell due to the symmetric property, and we multiply by 2. Okay, then we put in the value of 2 into the formula. 2 on 2, the integration from 0 to 2, t squared dt. Okay, then we integrate the t squared, we're going to get t cubed on 3 with the limit 0 to 2. 2 over 2 we have cancelled out and it becomes 1. Okay, when we substitute the limits, it equal to 8 on 3. Okay, now this is how you calculate an. An equals to, the formula is the integration of ft cos n pi t on L with respect to t from 0 to L, then multiplied by 2 because we solve this in half range. Okay, this is equal to 2 on 2. Okay, the integration of t squared cos n pi t on 2 with respect to t from 0 to 2. Okay, so since this is a multiplication of polynomial and cosine, therefore we're going to use tabular method. Alright, so this is the tabular method of the integration. We have t squared, differentiate t squared is 2t, differentiate 2t is 2, differentiate 2 is 0. Then we have the integration cos n pi t on 2. First integration is 2 on over n pi sin n pi t over 2 and etc. Okay, so you can try to do it yourself. Right, so therefore the solution of an is equals to, okay, how do you get this result? Is from the tabular method. Okay, be careful with the sign, cross multiplication. Okay, so we're gonna get 2t squared over n pi sin n pi t on 2. Okay, minus minus plus 8t over n pi squared cos n pi t over 2, and minus 16 over n pi cubed sin n pi t over 2. Then we have to substitute the limit. Alright, okay, this is when you substitute the limits. Sin n pi always 0, cos n pi is equals to negative 1 to the power of n, sin n pi here 0, sin 0 is 0. So an is equal to 16 on n pi squared negative 1 to the power of n. Alright, so we have obtained a naught and an. substitute into the formula of Fourier cosine series. So ft equals to a naught over 2, okay, 8 on 3 divided by 2 is 4 on 3, plus the summation of an is 16 over n pi squared minus 1 to the power of n, cos n pi t over L, where L equals to 2, n from 1 to infinity. Okay, so for the example 4.9, it's the same function, even function, so you can just refer to the slide and look at the solution. Alright, so let's move to the next example. Example 4.10, sketch a periodic function ft equals to minus t, t from minus pi to pi. Okay, and the fundamental period is 2 pi. Okay, based on the function given, the one complete cycle is from minus L to L, from minus pi to pi, therefore L equals to pi. Within the interval, negative 3 pi to 3 pi, okay, we're going to extend the function to negative 3 pi to 3 pi. It is whether the function is odd, even, or neither function. Hence, find the Fourier series of the function. Because this is how you sketch the function. In between negative pi to pi, ft equals to minus t. This is one complete cycle where t is equals to 2 pi. Okay, we're going to repeat this as t plus 2 pi. Okay. Then we're going to expand it to the right and to the left, okay, by period of 2 pi. The same plot, the same identical plot as what you have plotted in between negative pi to pi. Okay, so it's symmetric about the origin, therefore the function is an odd function. Okay, the Fourier series can be obtained using the Fourier sine series, odd function, sine series, ft equals to the summation of bn sine n pi t on L, n equals to 1 to infinity, L equals to pi. Okay, you have to write down the coefficient of a naught equal to 0 and as well a n equals to 0. Then you only need to calculate the bn. So bn, the formula is here. Substitute the L. L is pi, 2 on pi, integration from 0 to pi minus t sine n pi t on pi. So you can cancel out the pi here. Okay, you can just cancel out the pi. Okay. Alright. Then again, tabular method for solving the integration negative t to sine n t. Differentiation column we have negative t, differentiate negative 1, 0. Integration column we have sine n t. Then this becomes negative 1 on n cos n t. Second integration is negative 1 on n squared sine n t. Then we're going to write down the answer is from the tabular table is what you seen here. Alright. Okay. Then substitute the limits when t equals to pi. Then what you get here is for the first term when t equals to pi, then 2 pi on pi n cos n t. You cancel out pi, you get 2 on n cos n pi, minus 2 on pi n squared sine n pi, plus 2 on n pi squared sine 0. When we substitute t equals to 0, the first term is 0. So the second term becomes sine 0. Okay, again, useful in trigonometric identity. Sine n pi is 0, sine 0 is 0. Therefore, bn is equal to 2 on n negative 1 to the power of n. Alright, then don't forget, this is not the last answer, the final answer. You have to substitute the coefficients into the function ft. So ft equals to, into the series ft. So ft equals to the summation of bn. Okay, bn is 2 on n negative 1 to the power of n sine n t, n from 1 to infinity. Okay, there are few exercises, questions here that you can try to solve it by yourself. Okay, thank you so much for your attention. I hope that you enjoy the video.